Okay, in this part I'm going to solve exercises about the logarithm. I'm going to continue to solve exercises about the logarithm. Here, logarithm base 2, 3 value we are looking for, and if it logarithm base 3, 2 is equal to a in a part, we know this one logarithm base ab is equal to 1 over logarithm base ba. Here I recognize that 2 and 3, 3 and 2, so argument and the base, they replaced here. This is the argument, this is the base. So if I need the question, logarithm base 2, 3 is equal to what? So logarithm base 2, 3 is going to be equal to 1 over logarithm base 3, 2. In the question, logarithm base 3, 2 is given as a, so it's equal to 1 over a. Logarithm base 2, 3 is going to be equal to 1 over a. Okay, then b, and d, we solved this type of question, so I'm going to solve c. Yes, logarithm base 721 is equal to what? Here 3, 7, the base is 3 here, and I will replace this one as logarithm base 7, 3. It's going to be equal to 1 over logarithm base 3, 7. So logarithm 3, 7, it's going to be equal to logarithm 7, 3, 7, 3 is equal to 1 over p is going to be. Logarithm base 721 is equal to logarithm base 7. 21 can be written as 3 times 7. So this is going to be equal to logarithm base 7, 3 plus logarithm base 7, 7. This expression is equal to 1. We know that one. Logarithm base 721 is equal to 1 over p. Here we have found that one, plus 1. So logarithm base 721 is equal to p times 1 is equal to p1 plus p over p is going to be. Now in this part we are going to solve the questions in terms of a, but the logarithmic base, we have to be careful here. For the a, the logarithmic base is x, so I'm going to change the base. If you remember logarithm base a, b, if you want to change the base to c, logarithm base c, logarithm base c, I change the base to c, and what is written to argument, it should come to numerator b, and what is written to base, it should come to denominator, logarithm base cb, logarithm base ca. And here I change the base of the logarithmic expression. Now this question is changing base question. Logarithm base for the a, if we write what is written to numerator, it should be logarithm base x square y cube. It should be to denominator, what is written, it should be equal to logarithm base x squared times y squared. Okay, if we write this one as a common base, logarithm base x squared, and here logarithm base x squared times y cube, this is, so the operation between them, it should be plus logarithm base x y cube over logarithm base x squared plus logarithm base x y, this is x cube, so this is going to be x cube here. Okay, x cube. Then Then this expression here, you can get the powers in front of the logarithmic expressions, and it's going to be 2 times logarithm base x plus 3 times logarithm base x y over 3 times logarithm base x plus logarithm base y squared, I forgot here, 2 times logarithm base x y. It's going to be logarithm base x is equal to 1 here. This is going to be equal to 1, and xy, it is written here, and the value is equal to a. Then it's going to be equal to 2 plus 3a over 3 plus 2a is going to be. Second one now, b, logarithm base x and x cube base x cube y4 written up, and logarithm base x over y square written down. Here there is an operation between the logarithmic between the argument terms. Multiplication outside you are going to write as addition, x cube plus logarithm base x y4 over, it's going to be over logarithm base x. Here the operation between them, inside the logarithm we have division, outside when you write it's going to be logarithm base x y squared. You are going to get the coefficients in front, the powers in front as a coefficient, 3 logarithm x plus 4 logarithm x y over logarithm x minus logarithm 2 logarithm x y is going to be, okay, x here, these are equal to 1, we know, 3 plus 4a over 1 minus 2a, going to be solution. In this question we are going to use changing base formula, because normally 3 and 675 they are not related, 1 over 5 and 9 they are not related, and these numbers they are not chosen randomly. Here 625 and 1 over 5, you know, they are related, 3 and 9 they are related. So if I change the base, like logarithm base 3 625 can be written as different base, this base can be 10, logarithm base 10 625, logarithm base 3 10 3, it can be. So if we are like this, these numbers they are going to simplify each other, like logarithm, this is the a1, logarithm 3 625, I said 625 over logarithm 3 it's going to be, and times logarithm base 10 9 over logarithm base 1 over 5 base 10 1 over 5, it's going to be 1 over 5 to the power of minus 1 is going to be, and here logarithm base 1 over 25, I'm going to write 5 to the power of minus 3 over logarithm base 10 4 is going to be times logarithm base 10 1024 over logarithm base 10 5 to the power of minus 2 is going to be, okay. If we continue here, 625 I didn't write, but it is equal to 5 logarithm base 10 5 to the power of 4 over logarithm base 3 times logarithm base, this is going to be 3 square over logarithm base 5 to the power of minus 1 plus logarithm base 5 to the power of base 10 logarithm 5 to the power of minus 3 over logarithm 2 to the power of 2 times logarithm, if you remember, we said 2 to the power of 10 is equal to 2 to the power of 10 is equal to 1024 over logarithm base 10 5 to the power of minus 2 is going to be. If I get these powers in front of the logarithm, 4 times logarithm base 5 times 2 times logarithm base 3 over logarithm 3 times minus 1 times logarithm base 10 5 is going to be plus minus 3 times log 5 times 10 times log 2 over 2 times log 2 times minus 2 times log 5 is going to be. Okay, if we simplify log 5 and log 5, log 3 and log 3, here 4 times 2 over minus 1, which is equal to minus 8, and here log 2 and log 2, if we simplify, this is 10 times log 5 and log 5 if we simplify, and here is going to be equal to minus 30 over plus minus 30 over minus 4. When you simplify, this is going to be equal to 2 minus 2, pardon, plus 2, because both they are negative, 2, and here this is going to be 15. So the answer here minus 8 plus 15 over 2. If you multiply this term, 2 times minus 8 is equal to minus 16 plus, here we should multiply this 2, plus 15 over 2 is going to be, and that's equal to minus 1 over 2 going to be. For the B part, here all the bases are different, a squared, b cubed, c4, but what is written here also it is same. So I'm going to use the same method. I'm going to make the bases same, and I'm going to say logarithm b cubed here. This is logarithm a squared going to be times logarithm base c4 base 10 c4 is equal to logarithm b cubed times logarithm d5, the base is 10, over logarithm c4 times logarithm d5, pardon, logarithm a over logarithm d5, it's going to be, this is a, and as you see, logarithm d5 and logarithm d5, c and c4, c4 and logarithm c4 and logarithm c4, logarithm b cube and logarithm b cube, they simplify each other. So the only we left here logarithm a and logarithm a squared. So this is going to be equal to here logarithm base a over 2 times logarithm a, and it's going to be equal to 1 over 2, because logarithm a and logarithm a we are going to simplify. Okay, the next question. Now I'm going to solve these questions. Logarithm 2x when it is equal to 3 times something here, we can write 3 minus logarithm base 2 3 square plus logarithm base 2 5 cube is it can be. Why I made like this, I got the powers back, because here on this side we cannot add directly 3 with these expressions. I'm going to send this r to the other side, 2x plus logarithm base 2 3 square minus logarithm base 2 5 cube is going to be equal to 3 now. And the bases are same here, and we don't have any coefficient in front of the logarithm. So when there is a plus, we are going to multiply them. When there is a minus, we are going to divide them. So logarithm base 2 x times 9, which is 3 square, over 5 cube is equal to 125 is equal to 3. It's going to be x times 9 over 125 is going to be equal to 2 to the power of 3. What I made here, I sent this term to this side. Okay, if we continue here like this, logarithm base, logarithm we finished, logarithm part we finished, 9x over 125 is equal to 8 going to be, and x is equal to 8 times 125 over 9, which x is 8 times 125, it's going to be 1000 over 9. Okay, in this part the base is 3, logarithm 3, here also 3, here also 3, so I'm going to collect these terms to one side. Logarithm base 3x, here the sign is plus, but when you send to the other side it's going to be minus, so logarithm base 3 5 cube, and plus this sign is minus, it's going to be plus when you send to the other side. Base 3 4 square is equal to 2, it's going to be, so the sign is minus in front of the logarithm and we don't have any coefficients, so I'm going to do addition and subtraction inside the logarithm. You know, addition affects as multiplication, like x times 4 squared is equal to 16 over 5 cube is going to be equal to 125 is equal to 2. So I'm going to send this one to this side, and it's going to be exponential base now. 16x is equal to 16x over 125 is going to be equal to 9, 3 square it is, and x is equal to 9 times 125 over 16 is going to be, here these numbers, they are not divisible by 2, so we cannot simplify, and the result is going to be equal to 125 over 16 it must be.